In this video, we're going to have a look at dividing an integer by another integer with a decimal number as a result. So we are not going to look at dividing an integer by an integer with a remainder, but using our knowledge of decimals in order to work out an exact value, I suppose, if we divide it into fractional parts. So let's start off with a simple example like 10 divided by 4. Now traditionally we would say 4 goes into 10 twice with 2 remainder, so the answer would be 2 remainder 2, which is okay if we're dealing with dividing whole things into parts. So like I had Tim Tams and I divided it amongst 4 friends, how many would each friend get? 2 Tim Tams with a remainder of 2. That's fine. But sometimes we can deal with decimals just as well. So if I'm saying I've got 10 kilos of rice and I wanted to divide it into 4 equal piles, how many kilos would be in each pile? We can deal with that as a decimal answer. So let's have a look at that. So we're going to do it using short division. So in the time-honored tradition of how we do decimal short division, we write it like that. And we then start the division process as we would do for any integer division. So 4 goes into 10 twice. So 4 goes into 10 twice, like so. And that would leave me with a remainder of 2, which typically I would just write remainder 2, like I have up here, yeah? But instead, what I'll do is I will write a decimal point in, copy that decimal point straight up, and then stick a 0 on it. Bum, bum, bum. The good thing about that is just acknowledging that 10, the whole number, is the same as 10 and 0 tenths, which is the same as 10 and 0 tenths and 0 hundredths and 0 thousandths and 0 ten thousandths and so on. In other words, it's just using the property that I can add zeros after the decimal point, after any digits after the decimal point, without changing the number. 10 is the same as both of these things, so there's no dramas doing that. So why do it? Back to the problem. 4 goes to 10 twice, remainder 2. Now with a decimal point and a 0, I can take that remainder 2 and pop it down there in my next place. And then I can go 4 goes into 20 5 times. So 10 divided by 4 is exactly equal to 2.5. The 10 kilos of rice have been divided into 4 equal piles, each weighing 2.5 kilos or 2.5 kilos each. So that makes more sense in that context than 2 remainder 2 does. Okay, so this is the result from integer division, and this is the result from decimal division. Okay, and again, just to remind you that when I did 4 goes into 25 times, there was no remainder, no more digits after here. I mean, we could add zeros, but it wouldn't make a difference, and so that's where we naturally stop. Okay, so that's that. Let's look at a couple of other examples. So in this example, how about we try a fraction division? So what happens if I want to convert 3/8 into its decimal equivalent? Well, in order to do that, we are going to have to express the fraction as a division. Now, remember that if we have a look at the division sign, it's really showing us that it's a something over something else. Okay, the division sign is our key to what division really means. Division is really just a way of writing a fraction. So it's something over something else is our division. So we go top number divided by bottom number, numerator divided by denominator. So once we've got it into division form, we can now write that as our short division. In this case, the bigger number is over on the left. That's no drama at all, okay? Because even though we can say 8 goes into 3 0 times, so we can write 0 up here, it's not the end of the story, because I can put a decimal point here, copy it to the same place above, put in a 0, and in fact I might just put in a few zeros. I might not use them all, but I'm just going to get myself started with a few zeros there, and I can then continue the process. So I go 8 goes into 3 0 times, doesn't go in at all, which leaves me with a remainder of 8. That gives, no, sorry, it gives me a remainder of 3. Just delete that one. Sorry about that. Gives me a remainder of 3. That sounds a bit better. Again, if I know my 8 times table, I'm all right. 8 2s are 16, 8 3s are 24, 8 4s are 32. So it'll go in 3 times, but not 4 times. So it'll go in 3 times. 8 goes into 33 times. That's 8 3s are 24, so it gives me a remainder of 6. Then I can keep going from there. So what have I got? 8 5s are 40. 8 6s are 48. 8 7s are 56. And 8 8s are 64. So 64 is too high. So it's 8 7s. So I've put a 7 here for 56. And that leaves me with a remainder of 4. 8 goes into 40. Perfectly 5 times, doesn't it? 8 5s are 40. So I've run out of decimal places. I can add zeros, but they won't do anything for me. And I've got no remainder, so I can stop right there. So I can say that my fraction 3/8 is exactly equal to 0.375, like so. One more example. How about 5/11? All right, 5/11. Always a good idea to perhaps just inspect your fraction so you have an idea about what you're looking for here. 5/11, that's got to be close to a half, doesn't it? I mean, 6/12 is a half, 5/11 has to be close to a half. So let's keep that in mind as we go along. All right, first of all, let's write that as a division, 5 divided by 11. Now let's write that as our short division. And let's chuck in some zeros to start with. Again, just put in 3 just to start with. Doesn't matter if we don't use them all, or if we have to add more in later. Both is okay. So 11 goes into 50. Does 11 go into 5? Sorry, first of all, no. So I'll put a 0 there, a decimal point. And then 11, so that gives us a remainder of 5. 11 goes into 50. Now, my 11 times table is pretty good. 11 4s are 44. 11 5s are 55. It's not going to be that. So it's going to be 4. So 11 goes into 54 times. That gives me 44 with a remainder of 6. 11 goes into 65 times. 11 5s are 55. And that will give me a remainder of 5. 11 goes into 54 times. And that gives me a remainder of 6. So I'll have to put in another decimal place. 11 goes into 65 times. If you haven't got it yet, you will soon see that I'm getting a repeated pattern here. Oh, I have to extend my line here as well. 11 goes into 54 times. 11 4s are 44. 6 remainder. And I can see that I'm just continually getting either a 5 or a 6 as my remainders here. And my digits here are 4, 5, 4, 5, 4. So I reckon I know what the next digit's going to be. So 5/11 is equal to 0.45454 ellipses, and so on. But we know how to write that a little bit more succinctly. That means writing it as with as few digits possible. We can write that as 0.45 and then use our bar over the top to say that the 4/5 repeats. So 5/11 is exactly equal to 0.45 repeating. And again, if I just go back to what I said before about inspecting the fraction to start with, 5/11 I said is about a half, and I've got 0.45 here, and given that a half is 0.5, 0.45 repeating is pretty close. So I'd say that my answer makes sense, and so I'd have a pretty good sense of confidence that my answer is right. So that's it. That's how you divide an integer by another integer and get a decimal number as a result.